Well, welcome everyone, and thank you for joining us today. My name is Jonathan Firmer, and I'll be the moderator for this webinar. Today, we have a fairly exciting topic in which we're going to talk about our latest technology developments. Going to be interesting. Just a couple notes before we get started. The webinar is recorded. We'll send you an email with a link to the recording once everything's completed, probably in the next few days or so. This webinar will be about 45 minutes and then followed by about 15 minutes of Q&As. If you have any questions, that come up during the webinar, please put them in the chat for the entire webinar chat. And then towards the end,
if I may, in the Q&A.
In the Q&A, correct.
Thank you.
And we'll try to answer everyone's questions within 15-minute time frame. And lastly, if you'd like to learn more about any of the new products that we're going to mention in this webinar, we will share a link at the end, which you can use to have a Waterfall rep get back to you and find out more information how it could be, how it works for you. And that's it. Let's get started. Our first panelist, Andrew Ginter, VP of Industrial Security. And also we're going to have after that, Asaf Cohen. He's the solutions architect here at Waterfall Security. Turning the stage over to Andrew. Go ahead, Andrew.
There we go. Thank you, Jonathan. And hello, everyone. Welcome to the webinar. Thank you for joining us. We're talking today about Waterfall. We've got a some new technology we're going to go through. This is by invitation only to Waterfall customers. Often when we do webinars, we're focused on sort of the big picture of cybersecurity, the big picture of the threat environment. Today we're going to focus on Waterfall products and solutions. I've got Asaf Cohen, Senior Solutions Architect with Waterfall. He is going to take us through some demos of some of the new capabilities later in the webinar. And on the end, we do have, big picture threat environment. We have the new threat report coming out in a couple of weeks. I was going to give you folks a preview of some of the findings from the threat report. So let's, with that said, let's move on here. Give me a moment. Oh, I'm not sharing, am I? Let's fix that. Good. Okay. So, the big news technology-wise, we announced the Waterfall 600 product a number of months ago. The 600 is the 4th generation of Waterfall's technology. It is, stronger, it is faster, it is a huge investment. It's all new hardware. In a sense, it's all new software. It's a massive rewrite of the software, all of it for performance, for usability, for security, obviously, and simplicity. The whole solution. This is, again, it's the 4th generation. Think about sort of the evolution of technology, the classic evolution of a technology. The 1st generation or 2 are focused on just getting the job done. We're into the 4th generation. We have the opportunity now to take this mature technology and just make it simple, make it easy, make it, yes, of course, it's sort of the natural fit, the natural solution for a great many use cases. What does that mean specifically? Well, let's have a look at it. What is the same about this version of technology versus previous versions? What is the same is engineering grade unidirectionality. It is still physically able to send information in only one direction. It is a network appliance, fits into a rack. There is a DIN rail version coming. We still have the DIN rail version of the 500 available. The 600 DIN rail will be available shortly. In the rack mount version, if we lift the lid under the hood, we still see the physical divider down the center of the unit. And an auditor, you can run your fingers down that divider and verify that there is no cross connect inside the unit. Separate hot swap power supplies on each side, separate CPUs, separate everything. The only connection between the left and right sides of the unit are on the front panel, the fiber optic cable, the fiber optic transmitter on one side, fiber optic receiver, and the logic on the other side. This is a self-contained network appliance. All of the software that's needed, with one exception, that's remote screen view. All of the software needed to run the gateway is on the gateway. There is no need to introduce new hosts in other parts of the OT network or other parts of the IT network. There is no need to install software in other parts of the OT network or other parts of the IT network. You put it in, you connect to the web user interface, you configure the device, and it works. We can go, I mentioned performance. The device has, several models. The highest end model will go to 10 gigabits per second. We can do 10 gigabit copper. We can do 10 gigabit fiber. The device comes with a Waterfall OS on it. Where previous versions of previous generations of the technology used things like Red Hat or CentOS. Linux used Windows. None of that. It's Waterfall firmware. The firmware image has the operating system, has all of the connectors, has the user interface, has everything you need in the device. And there are multiple versions, multiple editions, if you like, of the 600 family. The high-end model will run, just about any scenario that you need. The marching orders, the mandate that was given to the development team when they created the high-end product, the mandate was, look at Waterfall's existing install base and reasonably project what that install base is going to look like in another couple of years, and design the product so that 99% of installations use what we ship, nothing extra. In very rare cases, you may need external hardware to do the most complicated installations, but 99% of the installations, if you need the performance, you buy the performance version, you put it in, and it works. And there is a lower cost, lighter weight version if you don't need all of that performance. 1 gigabit per second is still available. It's a question of what you need and putting what you need into a form factor that works for you. The focus again, security always, engineering grade unidirectionality. Self-contained, simple, reliable, and all of the performance that you need. That's the focus for the device. Dig into detail a bit, and what do we see? There's a web-based user interface. In the past, there were host modules. It was Linux, it was Windows. You could connect a keyboard and mouse. You could connect a monitor. These were hosts that had to be managed on the OT network and the IT network. That no longer exists. The device is a network appliance. You install you plug it in. You plug a laptop or something into one of the ports. You connect to the web-based user interface. The web-based user interface activates the licenses. It lets you configure the device. If once the device is up and running, you can monitor the device again through the web-based user interface. You can manage the device. You can start and stop connectors. You can manage your licenses. If you need to, you can even troubleshoot the device through the web-based user interface. It's all there. This is no longer modeled in your security program as a host. It's modeled in your security program as a device with firmware. There are no users other than the users you configure in the user interface. The user interface has multiple levels of users. You can have, people with full authority to do everything. You have, users that can monitor only or manage only. It's all, it's all there in the user interface. Something that, again, is in a sense the same as what you've come to expect is our connectors. We have an enormous number of connectors that connect to lots of different industrial control systems. As you well know, the industrial control system market is extremely fragmented. There are countless vendors, there are countless offerings, most of them specialized to a very specific purpose. What we find is that, if we're deploying this technology, in a fleet of 10 or 15 sites for an industrial business, no two sites are the same. In spite of every one of us trying to standardize our control systems, trying to make things as much the same, because that reduces cost. In spite of those efforts, there's just too much diversity out there. And this is why Waterfall has a huge collection of, things we can connect to, things we can make copies of. The hardware sends information in one direction. The software, these connectors, make copies of systems, so that on the enterprise network, the only thing that you need to do on the enterprise network is connect to the copies of the systems. All of the data that's allowed to be shared with the enterprise is out on the enterprise already. We no longer have the ability to risk operation systems by connecting to them and requesting data or doing other things to them, putting them at risk. So these are the connectors. And as you well know, some of these connectors are sort of, in a sense, single purpose. The Pi connector connects to Aviva Pi. Pick another one. The Yokogawa connector, connects to Yokogawa Exaquantum. But a great many of these connectors are multi-purpose. I'm going to be talking about OPC in a moment. The OPC DA connector alone talks to hundreds and hundreds of kinds of control systems. So it's not that, these are all that you can connect to. Many of these connectors talk to tens or hundreds of kinds of control systems. And so, as your needs evolve, we will be happy to work with you on, helping out with additional use cases, with additional replications that might be necessary over time. So that's connectors. A new feature. I mean, we've had high availability in the product for a very long time. And anyone who's done high availability knows that it's a little bit complicated, or rather, it used to be a little bit complicated. There was extra wiring involved. There was shared storage that had to be set up. There was external sort of domain controllers or other controllers that needed to be set up to manage the transitions between elements of clustered hosts. High availability is simpler now. Yes, you have a couple of extra wires to run because you have two network appliances, two Waterfall 600s. You run the wires because all of the data, all of the time, must go through both devices. Because on the receiving side, we don't know. There's no way for the receiver to tell the sender, hey, I'm alive, hey, I'm dead. And so all of the time, we send all of the data through both devices. We've been doing this forever, so that we're assured that even if there is a failure, if smoke rises out of some device, that the data continues getting through. Normally, 2 copies of the data get through, and the Waterfall devices coordinate to make sure that only 1 copy of the data winds up in the enterprise network. What's new is we no longer need external controllers. to manage, these you configure these hosts through the web user interface for high availability. They talk to each other, they figure each other out, they figure out their IP addresses. You don't need, we no longer need someone externally to say you're the master, you're the primary, you're the secondary. Oh, look, the primary just failed. Secondary, we don't need any of that. It figures it out by itself. So we no longer need external devices to manage the failover. We no longer need shared storage to manage the failover. The devices figure it out. And in the past, these devices had to be reasonably close together. Well, at this point, we're able to host these devices at quite a distance. So if you have, sort of the main server room in part of your campus, and you've got a failover, a fallback server room in another part of your campus, you can put one of these devices in the main server room. You can put the other device in the fallback server room. These can be separated by up to many kilometers. We do have to run a fiber from the one device to the other. So you have to be able to run that fiber. But if you can run that fiber, you can host these devices very far apart. Another use case that was possible with the 500, I just wanted to emphasize it's still possible with the 600, and that is hosting the transmit hardware in one room or in one building and the receive hardware in another. Why would you do that? Some of our most cautious customers have two server rooms, an OT server room and an IT server room, separated by some distance. And what they do not want is wiring from one server room to enter the other server room, because there's always a risk of human error. There's a risk that some well-meaning individual is going to pick up the wrong wire and plug it into the wrong device. And now you've got a cross-connect between your IT and OT networks. What a lot of people do is they want all of the transmit hardware in one server room, gathering data from the OT network, all of the receive hardware in the other server room, receiving data for the enterprise network. And the only thing passing between the rooms is the one or two, depending on high availability needs, the one or two fibers that are sending unidirectionally. That mode of operation still works. And, whereas with in terms of simplicity, with the 500 version, setting up high availability was a multi-hour job, even for an expert. There was just a lot of steps in the process. Well, it's no longer. I'm assured that, Asaf can verify, it's, for an expert, it's less than 1 hour. You set up the wires, you go to the user interface, the web-based user interface, you press a few buttons and bang, there you are. So again, fourth generation of the technology, we work hard to make everything easier. I wanted to say a few words about other features. And give me just a moment. Yes, okay, here we go. I was losing track of where I was in the presentation. Let's talk about connectors a bit. We have a lot of connectors. The development team is constantly producing new connectors. And one of the newer connectors I wanted to say something about, because I think it's going to be very popular in the future. I mean, today, a very popular connector is OPC DA, because it talks to hundreds of kinds of control systems. But setting up OPC DA is a bit of a bear, because there's DCOM involved. It's just, setting up DCOM on Microsoft Windows is just hard. OPC UA moves away from DCOM, and HDA is, there's different sort of chunks, the different segments of functionality within the OPC standard. HDA is historical data access. It is not talking to a PLC, it's talking to a historian. And again, we've got OPC HDA for the UA variant of OPC. OPC UA is easier to secure. If you have to run, let's say you've got internal firewalls in your OT network and you have to run decom through those firewalls, I'm sorry, you've got to open like 1,000 ports on the firewalls to let decom through. OPC UA goes through on a single port. It's much more firewall friendly when you've got sort of internal segmentation in the OT network. OPC UA, again, the software runs entirely in the Waterfall 600 unit. There is no software that needs to be installed anywhere else. With DA, often you were tempted to install some software on the DA server just to avoid decom because it was such a problem. But with UA, you don't have that problem. We can do remote connections easily. You go to the web-based GUI, you press a few buttons, you connect to the server, and off you go. It's all in the device. We have all of the features that you've come to expect of Historian connectors in this HDA. Let me speak to the diagram for a minute before I go into the features. How does it work? It works the way you expect. We've got a plant historian. It might be Wonderware. It might be Aviva Pi. It might be a Siemens historian. You might have lots of different kinds of historians in different plants. Most of them today, almost all of them, have a historical data access interface that can be accessed through OPC UA. So in this scenario, let's say we've got a plant or 6 different kinds of plants, each with a different kind of historian. The Waterfall software on the internal side, on the OT side, on the industrial side of the device, that software connects to the historian database through HDA, through historical data access. It requests from the database all of the data that is new since the last time we connected, a second ago, gets the new stuff, pushes it through the strange, one-way hardware with the strange one-way protocols. And on the outside network, on the enterprise network, the UA connector is a standard UA HDA server. It's emulating, in a sense, the plant historian. It's emulating the OPC UA interface for the plant historian. It has in its head a lot of the data. I forget how far back it goes. It's probably configurable, but it's generally not a complete copy back to the beginning of time of the plant historian, but it is a copy back to days or weeks or months ago. And that data is sitting there waiting for someone to ask for it. Who asks for it? 9 times out of 10, the enterprise historian asks for it. You might have a Wonderware historian or an Exaquantum historian, in your industrial network. You might have an Aviva Pi on the enterprise network. The Aviva Pi would connect to the OPC HDA server, the Waterfall server that's built into the Waterfall 600 appliance, connects to that server and requests the data and populates the enterprise historian with data. Now, anyone who needs the data from any of the plants, from any of the kinds of historians in any of the plants, can go to the enterprise historian, whatever it is, connect to it, and get the data. So that's the mode of operation. Again, more secure. It is, just in terms of managing connections inside the OT network. Native, nothing needs to be installed. Okay, the enterprise historian connects to our OPC UA HDA server normally across the network. We connect to the original plant historian normally across the network. There's backfill. If something fails somewhere, most commonly if we install new firmware or upgrade software somewhere, we're going to see a gap in the data in the enterprise historian. We want that fixed. You press a button on the web-based user interface on the industrial network, it resends whatever data you've requested, and you fill in the gaps in the enterprise historian without duplicates. the other features of OPC that you've come to expect, metadata. What does that mean? That's tags. You define the tags on the OT network, on the industrial network, and if you choose, it's optional. You press a button. You say, if I see new tags in the plant historian, I want those tags made available on the enterprise network. Most people do this because they don't want to enter the data twice. And now, once the data is out there in the OPC HDA server on the enterprise network, you can configure the enterprise historian any way you want. Often there's a way to tell the enterprise historian, if you see new tags in the HDA server, pull that data across, so that you don't have to configure the tags 2 and 3 times. It just works automatically. Sometimes you want to configure them 2 or 3 times because maybe different groups are responsible for the different devices, and they don't want other groups to be able to create tags in their devices, even if it's automatic. Fine. This is an optional feature. Most people replicate the entire plant historian into the enterprise historian, no exceptions. Sometimes, there's proprietary recipes. Sometimes there's, NERC SIP data that cannot be shared from the industrial network out to the enterprise for regulatory reasons. In that case, you can select the subset of the plant historian that you're going to make available in the enterprise historian. And again, the last tag here, I've talked about, you can have different historians inside versus out. So that's sort of something that a feature that I think is going to be very popular in the future, so that because it's so easy to do, and because it lets you connect different kinds of historians together very simply. And finally, I'm going to take you through real quick an entirely new product offering from Waterfall. This is a software only offering. It's not, in a sense, you don't get it with the Waterfall 600. This is when we have many Waterfall 600s, many Waterfall devices in a plant. When we have many plants in an enterprise, we might have 5 or 10 or 30 or 40 unidirectional gateways deployed in an enterprise. And, we've got enterprises that big. 9 times out of 10, we have a network operations center, we have a security operations center, and we want to see as much as we can on one pane of glass. So Waterfall Central is a central way to visualize what's happening in all of our industrial, all of our unidirectional gateways. One pane of glass, a central dashboard, aggregates data. What's it aggregate? It aggregates data about performance, how much data is going through, about which connectors are turned on and turned off, about alarms, if any alarms are coming through saying, hey, I lost contact with the enterprise historian, someone should probably look at that. You can use this tool to define custom alerts, saying, look, if I see A and B and C, I want Fred notified, because Fred's the one responsible for A, and A is the one caused the problem. You can do custom alerts. There's a bunch of automatic alerts that are built into the product, and the product, can run standalone. It has a user interface. It's also thoroughly integrated with SEMs and SOARs, so that security operations centers don't need 2 panes of glass, one for the gateways and one for everything else. They can integrate all of the Waterfall Central data into their sort of normal user interface in their security information and event management systems, so that it's all there in one place. At this point, oh, pardon me, I've gone through this. I think I've told you all this already. Custom rules, there's a learning mode. It can learn what's normal in terms of throughput, in terms of connectors up and down, and raise alarms if anything deviates from normal. I think I've said this. Asaf, have I missed anything? I think it's time to hand this over to you.
Oh, thank you. No, you covered the the most important aspects of the Waterfall Central, and I can take it from here. So I will just briefly share my screen. Here it is. Okay, so what I would like to talk about today, and not just talk, but show and tell. So I will tell about it and also show it. It's a live demo of a scenario when we want to transmit and send MQTT messages, messages from the industrial or the OT network, and send them securely over to the cloud. In this case, it's the AWS cloud. AWS has a component, they call it the IoT core, which is actually just, not just, it is a fully functioning MQTT broker that you can send messages to. And once those messages, this data is in the cloud, you can then use the data for any further processing. So in this demo, I will show you a setup, a fully working setup of an MQTT client publishing messages through a Waterfall Unidirectional gateway, and then from there to the AWS cloud, and where for the demo, I am not processing these messages for any maintenance or anything like that, but I prepared a nice graph. So in the changes in real time, so we'll see it in a moment. Okay, so just a quick, I'll just briefly go over the diagram and talk about the different components and what exactly is happening, and then we'll jump into the actual demo. So we have on the OT side an MQTT client that publishes the messages, and on those messages are sent to the Waterfall transmitter that resides on the OT network. The Waterfall software on the OT network acts as a native MQTT broker. It supports TLS, encryption of the messages. It supports any type of certificates in a PEM format. So our customers can upload their own certificates, even if they're self-signed. And those messages are then replicated or moved unidirectionally to the IT side, to the receiving module, the RX module of Waterfall. On that side, the Waterfall software acts as an MQTT client. It does two things. First, in this setup, it authenticates with the AWS platform using the certificates that are generated by AWS. It performs the authentication, and then it republishes the messages that originated from the OT side. It republishes those messages into the AWS cloud. So I will now briefly go to show you the data source. This is the MQTT client that we can see on Grant. Here it is. This is the MQTT client on the OT side, the industrial side. I used for this demo an open source software called Rapid SCADA. The only reason I use that is, is that it can act as an MQTT client, and it has this nice graphical representation of the data. So what we see here as the data source, it's sort of a server room with 6 different data points that changes in real time, and they're supposed to represent temperature, which is the T1 to T5 on the upper side, and another, the 6th one is represents humidity. So this data is generated and changes randomly within given limits. So this is the MQTT client basically on the OT side. And now I will jump to a big leap to the IT side. Just refresh this page. Here it is. As you can see, in the address bar, this is on the Amazon AWS cloud. So this data originates from the OT, and the only connection between the OT side, the source or the original MQTT client to AWS is via a unidirectional gateway by Waterfall. So once this data is in the cloud, you can do it pretty much anything that comes up to mind. I chose to create pretty graphs that can be used in demos. So we have the upper graph that shows 3 of the data points, another graph that shows 2 of the data points, and you can see that it changes in real time based on the data that is generated on the OT side. Just some technicalities about the demo. All of the data is sent as JSON, in JSON format, as the payload of the MQTT messages. So all of the processing is done, and the parsing of the JSON and extracting the data and putting it on the graph or on any other place in the AWS. All of that is performed on the cloud. So it really it doesn't require any processing power or anything like that on the industrial side of the network. And Andrew, is there anything you would like me to, you think I should talk about or mention about the demo or the setup?
No, I mean, it's you've gone through it. Maybe just a word of context. One of the reasons we thought we'd show you folks the MQTT is because, again, we think it's going to be very popular going forward. MQTT seems to be emerging as the sort of the default protocol to connect industrial systems to cloud systems. In years past, these protocols were all over the place. We seem to be standardizing on MQTT. We're also seeing MQTT, as Asaf mentioned, in data centers, on the OT side of data centers. And many of our largest customers have their own data centers, or are renting space in other people's data centers. These are facilities where uptime is vital, and we cannot allow any kind of cyber messing around with the OT network, because that just messes up with our uptime statistics. So data centers are something that's something new to think about in terms of what we need to protect. MQTT is something new in the world of cloud connectivity, and cloud connectivity is coming. I mean, I remember years ago I was talking to a Waterfall customer talking about, cloud connectivity. And they said, Andrew, don't want to waste your time here. Don't want to waste our time. We have a strict policy. You should know this, strict policy. No industrial connectivity to the cloud ever. And I said, bear with me. And I showed them MQTT and other connectors. I showed them how to connect to the cloud safely through the unidirectional gateway. And their answer was, look at that. We're going to have to change our policy. So, there are huge benefits to be realized by pushing some, not all, some of our data into the cloud and, analyzing it and profiting from access to that data. So, MQTT I see as one of the futures, one of the connectors we're going to see that's very popular in the future. And again, it's available to all of you customers just by calling up Waterfall, and let's talk about getting it onto your equipment or upgrading the equipment to the 600 where we can deploy it for you. With that said, I was going to switch gears and say a few words about the threat environment and then open it up to question and answer. So let me jump in here. So threat environment, this is from the new Waterfall threat report that has not released yet. This is sort of a sneak preview for you folks only. The threat report, what have I got here? There we go. The threat report looks at, we look at physical consequences, okay? We look at deliberate cyber attacks, not errors and omissions, not equipment failures. We look at deliberate cyber attacks that caused physical consequences. Plants shut down, equipment was damaged. We saw one this year where a fire was started. So deliberate attacks, cyber attacks with physical consequences in the industries we track, which is building automation, manufacturing, and heavy industry, critical industrial infrastructures. All of it in the public record. Okay, no private disclosures. Every attack we report on, you can go to the appendix. Half of the report, it's actually quite a short report. It looks 35 pages, but the last half of the report is one massive table in the appendix with the entire data set. If you look at these reports and go, how real are these? You can page through the data set. You can click on the links and you go to the front page of the New York Times or the Washington Post saying, here's the details of the attack, and judge for yourself if it meets the inclusion criteria. Public record. So we know that this report is an underestimate of what's happening in the world because we're a vendor in the space. Our customers come to us and they tell us about attacks that they've observed in plants. This is why they want to talk to us about using unidirectional gateways. We've had attacks disclosed to us that we do not count because they're not in the public record. So this is sort of it is the most cautious underestimate of what's happening in the threat environment. What's happening is we went from a decade, 2010 through 2019, where we bounced around between, between 0 and 5 attacks that met this criteria every year. Where, it was sort of, this kind of outage was mostly a theoretical problem that decade. This decade, we see what looks like exponential growth. It's noisy, it bounces up and down, but we're, this in 2023, the data set for 2023 has 68 attacks in it. 2019 had 5, 2020 had 18, 21 had 23, then there was 57, now there's 68. It looks to be almost doubling annually. And let me say, a lot of these attacks are ransomware. And a lot of the ransomware is very sophisticated. These ransomware threat groups, they're using the tools and techniques that, 5 years ago, only nation states used. Some of these ransomware groups are actually backed by nation states. North Korea backs a bunch of their ransomware groups because the groups make foreign currency for the sanctioned regime. They steal it, but it winds up in the pocket of the sanctioned regime. Nation states are backing ransomware groups. Some of the ransomware groups are so wealthy, they can afford to build their own very powerful attack tools, very similar to the kinds of tools that nation states are using. They can afford to buy nation state grade attack tools on the black market. There was a time 10 years ago when we would look around and say, yeah, but we're just a medium-sized power plant. We're just a smaller water treatment system. Why would a nation state come after us? Well, today, ransomware groups, the most sophisticated ransomware groups, have the tools and techniques of nation states, and they're coming after everyone with money. Do we have money? Yes. Then sooner or later, one of these powerful ransomware attacks is going to come after us. This is the new reality. What else have we got? Again, there's a lot in the threat report, but a couple of items. One is Volt Typhoon. Now, this is listed in the report as a near miss. It is not listed it's not counted as an incident because in spite of more than 50 US power plants being compromised by this Chinese attack, more than 50 plants were compromised and there were no physical consequences. The lights stayed on, and most of these were power plants, power utilities. Why is it important? Why are we talking about it? It goes into our section of the report called near misses. And these are attacks where if the circumstances had been a little bit different, if the intent of the adversary had been a little bit different, we would have seen physical consequences. Why is this important? It's because this attack has been lurking, has been hanging around in a lot of these victims for between 6 months and several years. This is a long-term attack. Gathering, the US intelligence agencies are saying, in their best estimation, this attack is gathering information to use in future attacks that have physical consequences. The attack is very difficult to detect. A lot of us, a lot of industry, think, I don't know, manufacturing. Half of the incidents in last year in the report, in the most recent data set, half of those incidents were ransomware. Half of those incidents were manufacturing. We're targeting manufacturing. Plants went down. Multiple plants tended to go down in each of these attacks. There were like 500 sites affected by these 68 attacks. And a lot of the manufacturing out there, a lot of us think, well, I've got intrusion detection. I've got incident response. I will detect the bad guys. I'm good. The problem is that intrusion detection has a really hard time detecting this kind of attack because it's called living off the land. There is no malware that's in the machine. You look at the machine and it looks like a normal machine. It's running normal processes. It's running software that's allowed to run on the machine. The bad guys are using existing facilities, normal facilities, to connect by VPN through whatever two-factor to, remote control machines, most of them on the IT network. Now, there is evidence that this attack has tested out the ability to reach into OT networks, but most of the time, they're just hanging around on the IT network, waiting for the order. The intel agencies tell us, waiting for the order to do something worse. So this is disturbing in terms of its sophistication, the difficulty of detecting it, and its apparent intent to eventually cause harm. Something else that is mentioned in the report, but this is something that's actually coming later in the year. This is a different kind of threat report that Waterfall is putting out. We've got people in my group doing research. This is Dr. Jesus Molina. I'm going to give you a sneak preview of some of the research he's done. He's looking at artificial intelligence. The new buzz for the last 12 months has been ChatGPT. It's a new kind of artificial intelligence that's really easy to use. I'm guessing everyone on the call has tried out either ChatGPT or one of the competing AIs that are like ChatGPT. This class of AI is currently being used routinely for different kinds of things. It's being used to pretend to be tens of thousands of, well, internet trolls, people who post crap on the internet that makes people angry, that gets people angry with their government, with each other, sowing discord, interfering with elections. It's also used routinely for stage 1 attacks, crafting phishing email that's really convincing. Now, on the defensive side, to be fair, AI generally has been used on the defensive side for years as well to try and figure out, I've got millions of alerts coming in, which of these really are attacks, which of them are not. What's new, what Waterfall is doing is looking at stage 2. Assume the bad guys can get into the IT network. Stage 2 is reaching into the OT network and causing damage. Can we use ChatGPT to do that? And so far, the answer is, if you've got a script kid, if you've got someone who has no idea how turbines work or what Modbus is or any of that, no, they cannot use ChatGPT to create a stage 2 payload. If you've got someone who does know what they're doing, ChatGPT can, and similar, there's a whole family of AIs out there that are sort of cooperating here. Those AIs can speed up the creation of very sophisticated stage 2 attacks, speed it up enormously, 5 to 10 times. So what we're seeing is that these AIs are not creating new attack opportunities, they're amplifying the abilities of capable attackers to make them even more productive in terms of attacking us. So, the bottom line is the world is becoming a more dangerous place. And this is why Waterfall exists. Waterfall was created, 15, 18 years ago now, specifically to address these very sophisticated attacks, the attacks that are becoming ubiquitous in today's internet. The very latest Waterfall is the Waterfall 600, faster, simpler, more powerful, simpler, high availability if you need it. Something like 3 or 4% of our customers need high availability. It's now simpler than ever. We've got connectors that are sort of going to be the future of industrial automation that I believe are going to become very popular over time. We have all of our old connectors as well. We have a new way to visualize what's happening in our industrial networks, and there's more stuff coming. Can't tell you about it, doesn't exist yet, or rather not ready for prime time yet, but this is the latest. Come to the Waterfall website if you're not on the mailing list. Visit one of the blog posts. It's gonna give you an option to sign up for our newsletter and stay in touch, because there's other exciting new features and entirely new products and new capabilities coming. That's what I had for you. We were going to post in the chat a link if you folks would like to reach out to us. There's a link you can click on and you can have one of our experts call you. If you want to reach Asaf, if you want to reach me, our email's up on the screen here. Reach out to us. That's what I had. Asaf, did you want to say anything more? And Jonathan, do we have questions? How do we go forward here?
Asaf, if you have anything else to wrap up, and then we have a few questions. So, Asaf, anything?
No, I have nothing to add.
Okay. So we had a few different questions come up during the while Andrew was presenting and Asaf was presenting. Let's see here. Someone wrote that it's an anonymous question. What is the size of the buffer between the RX input and the TX output route? Is it possible to control the transmission output rate when the next device in the chain can receive a low rate?
Yes, I can answer that. The answer is yes, there is a buffer, and it depends on the host server's available random access memory. So the bigger the RAM is, the larger the buffer can be, and it is configurable using the Waterfall configuration tool, the software. Our customers can configure how large this buffer will be.
And if I might add, it depends on the model. If you've purchased the performance model, I think it ships with something like 128 gigs of memory. There's a lot of memory available for buffering if you need it.
Okay, thanks, guys. I hope that answers the question the person asked. We have another few questions I see that were asked here. First of all, someone was asking if they can get a link to the video and to the presentation. We will send everyone a link to a recording of this webinar, which obviously includes seeing the presentation. I don't know if we have a file that we're sending out directly to the presentation. I'll have to get back and see if we could do that. We have another question here that's directly related to the technology. How is it possible to maintain a TLS handshake with a unidirectional solution?
Yeah, I'll take that. So to maintain a TLS handshake, the key is, well, it is sometimes counterintuitive for those who are unfamiliar with how, well, you hear unidirectional, you think UDP, and so how is it possible? So the key is to remember that the handshake is, there are two handshakes actually, or two sessions. One between the source device on the OT network and the Waterfall module, and another one on the IT network between the Waterfall receiving module and the destination device. So it is actually two different sessions taking place, and there is no need for the source device to talk directly to the destination device.
You've gone on mute, Jonathan.
Oh, sorry about that. Do you guys hear me now? Thank you for the answer there, Asaf. I hope that answered the question to whoever asked it. Hope you guys hear me now. Yeah, I'm off mute.
Yep.
So let's go to the next question because we're about to run out of time. Is it required to use specific certificates, or can each customer use their own? Are there self-signed certificates supported? Who wants to answer that?
Yeah. So as long as the certificates are in PEM format, meaning they can be read as text, you can use them, and self-signed certificates are also accepted, and the customer can upload their own certificates to either side of the unidirectional gateway. It is even possible to use different sets of certificates, one set for the OT side and a whole different set for the IT side.
Yeah, let me add to that. Part of the reason there, part of the philosophy is that it's not, there's no TCP connection going through the device. The device is not a router. The device most often is a client on the industrial network. Let's say, gathering data from a historian, and a client on the enterprise network, updating that historian with the data. These are two independent client connections. Each of them has their own encryption. Each of them has their own sequence numbers. It's, we're not forwarding network traffic from one device or from one network to another. We are synchronizing servers, much like the Aviva Pi to Pi offering does, much like the Microsoft SQL to SQL offering does. We're synchronizing the servers through the unidirectional hardware.
Okay, thanks, Andrew and Asaf, for answering that. Well, let's just do one more questions, and then one question will wrap it up. We have another anonymous question here. Why would I use HDA rather than DA to get data to our enterprise historian?
Well, I talked about the difference in terms of setting up DCOM and whatnot. A lot of our customers have done the job of setting up DCOM, all that painful process. And you might ask, why would I want to upgrade from DA to HDA? What do I get if I upgrade? And what we get is backfill. That's the difference. Think about the OPC DA, even an OPC UA DA. DA is what is it? Data access? Thank you. It is a programming interface that runs over DCOM. It's not really a protocol, it's an API. What functions are supported in the programming interface? There's functions saying, can you tell me what tags are out there? Can you create groups of tags for me? There's functions saying, can you give me the value of these tags? That's it. Those, you've got a few, like a dozen or a dozen and a half functions you can call. And the only function that gets you data is the one that says, can you give me the data for the tag? That function, you put in, a tag name or a group name. There is no timestamp in that function. There's no time range given to that function. It gives you back the current value. That's all you can ask for. And so if we update the firmware, if, something changes, where there's some sort of gap for 5 minutes in the enterprise historian, DA cannot fill it in, whereas HDA has the backfill capability. HDA will let you fill in those gaps. So, this is why, people might have deployed DA in the past, because it was sort of the obvious thing to deploy. It was the most compatible thing around. And we put up with what we put up with in terms of manual processes to fill in these gaps if they arise. It can all be made automatic with HDA. This is why we see people upgrading to HDA over time, why I believe more and more people will upgrade to HDA, because it gives you the ability for backfill. It's just more convenient.
Great. Thanks, Andrew, for answering that question. We're just about out of time, so let's wrap it up. Let me just tell everyone that if you'd like to have either give feedback on the webinar, and also if you'd like to have a Waterfall rep contact you about the different products that we recently offered, there's a link in the comments. You could put it in there, give your feedback, and have someone contact you. And I hope everyone found this webinar informative and relevant to their work. We're going to send you within the next few days an email with a link to the recording. You probably get that in the beginning of next week. Thank you, everyone, for joining. Thank you, Andrew, for joining us. Thank you, Asaf. And hope everyone has a great day. Thank you very much.
Thank you, Jonathan. Thank you, Asaf. Thank you, everyone.